Welcome to this explainer. Today, we are exploring a truly fascinating transformation, and that is bringing life into your static enterprise data. In modern business, data is honestly a massive bottleneck. It just sits there, right? Trapped in these isolated silos, flat files, or rigid databases, completely inaccessible to the very people who actually need it to make decisions. So today, we're pulling our insights directly from Miguel Figueredo's fantastic book, Generative AI with SAP and Amazon Bedrock. We are going to completely zero in on the hands-on architecture he lays out in Chapter 6, specifically covering pages 285 through 374. We are going to look at exactly how we can use Amazon Bedrock, SAP, and AWS to take all that locked-away data and turn it into something you can literally hold a conversation with. All right, let's dive right into this and see how this data journey unfolds. Okay, so here's our roadmap for today. First, the GenAI workspace setup. Second, analyzing SAP financial reports. Third, conversing with SAP HANA. And fourth, automating with AWS Lambda. Section 1, the GenAI workspace setup. Now, every great data journey needs a solid launchpad, and getting started here is, well, it's astonishingly straightforward. First, you just launch Amazon SageMaker Studio. Next, you select the Data Science 3.0 image running on Python 3. And honestly, the value of this single step really cannot be overstated. By bypassing all that complex back-end provisioning, data scientists can literally start experimenting in minutes rather than waiting weeks for IT approvals and infrastructure setups. It's a real game changer. Then, you just rename your fresh Jupyter notebook to keep things nice and organized, and finally upload your core utility files. This completely removes the friction that usually stops enterprise AI projects before they even get off the ground. If you take a look here, preparing for heavy-duty analysis is literally as easy as dragging and dropping files. You just pull your zipped utility files, like the myutils.zip archive, and your static SAP PDF reports straight into the root folder. And those utility files are absolutely crucial, by the way. They contain the helper scripts for securely handling things like API keys and environment variables, which keeps your primary notebook totally clean. You really don't need to be a command line wizard to get your data into the AI's hands and securely configured. Section 2, analyzing SAP financial reports. So with our workspace primed and ready, let's transition to the next phase. Take a look at this. This right here is the reality of enterprise data overload. What you are looking at is a super dense, multi-page SAP General Ledger Account Balances PDF report. I mean, you have endless columns carrying forward balances, debits, credits, mixed currencies like euros and US dollars. If you handed this to a human financial analyst, it would take them hours of just squinting at spreadsheets to manually extract any meaningful, high-level insights. It's comprehensive, for sure, but it is deeply, deeply static. It makes you wonder just how much enterprise value is locked away simply because humans don't have the time to read it all. Now, this is where the magic happens through prompt engineering. Instead of writing all these complex parsing scripts, we simply frame the AI with a specific persona. We pass what is called a system prompt to the Claude large language model via Amazon Bedrock. Think of a system prompt as the foundational brain of the interaction. It stops the LLM from hallucinating outside of its assigned role. Our prompt says exactly this. You are a great finance analyst which can analyze the health of a company based on a financial report. By giving the LLM the strict foundational persona alongside instructions to provide an executive summary, we completely change how the model interacts with that dense wall of text. It stops reading it as just disconnected numbers and starts reading it as a unified narrative about a company's financial health. And boom. This brilliantly illustrates the immediate payoff. Within seconds, the AI outputs an executive summary, instantly extracting the crucial figures. It seamlessly pulled out that the company generated $4.2 million in domestic revenue. It identified cost of goods sold, noting $1.69 million in direct materials. It aggregated the cash positions to reveal over $300 million in bank balances. And finally, it flags $600 million in short-term bond payables. What would literally take a human hours was achieved instantly. The disparity between that dense, impossible-to-read PDF and this incredibly clean, actionable output, that represents a massive leap in the productivity of any financial manager reviewing this data. Section 3, conversing with SAP HANA. Okay, so we are now escalating from reading static documents to actively chatting with a live relational database. Imagine having to query a massive database to answer this super simple question. Which hotel has the most number of nights reserved? Traditionally, a manager would have to submit a ticket to IT, wait around, or write a really complex SQL query joining multiple tables. But with GenAI integrated into SAP HANA, we use a library called PandasAl. Conceptually, PandasAl merges generative AI capabilities directly with standard data manipulation libraries. It acts as this highly intelligent bridge. You just type that exact natural language question directly into your notebook, and PandasAl handles the heavy lifting of figuring out how to get the data. And here is the incredibly satisfying visual answer. Because we instantiated Bedrock Claude as our large language model within PandasAl, the system understood our plain English prompt, automatically translated it to query the SAP HANA database, and instantly outputted this result. Notice the bar chart here? The Atlantic Hotel takes the lead with nearly 20 nights reserved. This is literally data visualization on demand, powered purely by conversation, no SQL required. But, we can push the boundaries even further. We've asked a simple fact-finding question, but what happens if we shift to an analytical command? This perfectly highlights the immense flexibility of the LLM. With just a single sentence, we type, "Provide full analysis of this data for a hotel manager." So the really crucial point here is how the AI interprets that broad command. Looking at the resulting output, it didn't just give us one chart. It provided the total number of reservations, it printed out a clean table showing reservation nights by specific hotels, like Indian Horse and Airport, and it even calculated the average nights per reservation at 6.57. Then it wrapped the whole shebang up in a formatted visual plot. What you should take away from this is how incredibly it democratizes data access. A hotel manager no longer needs to rely on a data science team or submit endless IT tickets to get their daily visual reporting. They can just ask their data directly. It fundamentally changes the entire relationship between business leaders and their enterprise data. Section 4, Automating with AWS Lambda. Now for the technical climax of our explainer. Everything we've seen so far in the SageMaker notebook is brilliant for a data scientist. But how do we actually scale this for the entire business? Well, we do it by packaging these conversational capabilities into a reusable, automated API. To understand what our Lambda function is doing here, we need to clearly define text-to-SQL. Basically, this is the process of automatically converting natural language prompts, those plain English questions we just looked at, into executable database queries using AI. Our goal here is to create an API endpoint. And why is an API endpoint the ultimate goal? Because it allows this entire intelligent workflow to be integrated directly into existing enterprise apps. You could hook this up to a Slack channel, internal business dashboards, or even custom software. Any application can send a question, and the API will translate it to SQL, run it against SAP HANA, and return the answer securely. For the builders in our audience, this slide reveals the actual engine under the hood. This is the Python code living inside the AWS Lambda deployment package. You can see the setup where the Boto 3 client connects to Amazon Bedrock. And Boto 3 is simply AWS's software development kit for Python. It's just the library that allows your code to talk directly to AWS services. Let's trace the logic flow here. It's like a relay race. It starts with the user input coming in. The Lambda function takes that input and sends it to Bedrock to perform the text-to-SQL generation using a specific function. That generated SQL query is then executed directly against the SAP HANA database. The raw data comes back from SAP, and Lambda sends it back to Bedrock one more time, using another generative function to frame that raw query result into a natural, easy-to-read language answer. And finally, that polished user output is delivered. So it goes user input to Lambda, to Bedrock, to SAP, back to Bedrock, and out to the user. It seamlessly and securely bridges the gap between the end user's prompt and the backend database. We've really covered a lot of ground today. We've gone from setting up a simple workspace, to summarizing those dense financial PDFs, to visually chatting with a live SAP HANA database, all the way to packaging the whole thing as an automated AWS Lambda API. As Miguel Figueiredo so perfectly outlines in Chapter 6 of his book, generative AI has the potential to create massive business value by building completely new conversational experiences. Your enterprise data is no longer static. It is literally waiting to be spoken to. So, the only question left to consider for your own business is this: what will you ask it first? Thank you for joining me on this explainer.